Hello everyone, welcome to my channel. Today we are going to discuss second exercise of chapter 2 Polynomials exercise 2.2. First question is find the zeros of the following quadratic polynomial and verify the relation between the zeros and the coefficients. So the first part is our polynomial is x square minus 2x minus 8. So we will solve it by using the method of factorization, which is the splitting of middle term. So here we can see we need two numbers of which the product is minus 8 and sum is minus 2. So those two numbers can be minus 4 and 2 respectively. So we can split the middle term, as you can see. Then we'll get two zeros, x equal minus 2 and 4. So first part of this question is solved. Then next part is to verify the relation between the zeros and the coefficients. So we are taking the zeros as alpha and beta, and the first relation is alpha plus beta equal minus b upon a. We will solve both the part LHS and RHS. We will add the zeros, minus 2 plus 4, which will give 2, and minus b upon a, which are the coefficients of x and x square respectively in the polynomial. We will get 2. Hence the first relation is verified. Similarly, for the second relation, it would be alpha into beta is equal to c upon a. In this we will take product of the zeros and coefficient of and the constant term and coefficient of x square, which we will get as minus 8. Hence the second relation is also verified. Now the second part, which is polynomial, is 4s square minus 4s plus 1. In this again we need two numbers for which the product is 4 and sum is minus 4. So the two numbers are minus 2 and minus 2. We will get s equal 1 upon 2 and 1 upon 2. We will take the first relation for verification. Alpha plus beta is equal minus b upon a. For LHS we will take alpha plus beta, which is 1, and minus b upon a, RHS, which is also 1. So first relation is verified. Then second relation, alpha into beta, is c upon a. For LHS we will find product of zeros, and for RHS we will find c upon a, which we will get both as 1 by 4. So our second relation is also verified. Next polynomial is 6x square minus 3 minus 7x. In this we have to adjust it in the standard form, ax square plus bx plus c. So it would be 6x square minus 7x minus 3. So we will find two numbers for which the product is minus 18 and the sum is minus 7. So the numbers are minus 9 and 2. And after solving this by factorization, we will get zeros as minus 1 by 3 and 3 by 2. For verification, we will do the step first. Sum of zeros alpha plus beta would be 7 by 6, and RHS minus b upon a would also be 7 by 6. So our first part of verification is proved. For the second part, alpha into beta is c upon a. So LHS would be product of zeros minus 1 upon 3 into 3 upon 2, which is minus 1 by 2, and RHS would be c upon a, which is also minus 1 by 2. Our second verification is also done. Coming to the fourth part, our polynomial is 4u square plus 8u. In this, we are not given the constant term. So we will do it by taking factors which are common in both the given terms, 4u square plus 8u. 4u is common, so we will take it out, and in the bracket we are left with u plus 2. After solving, we will get zeros as 0 and minus 2, which are our alpha and beta. For verification, for the very first part, alpha plus beta is minus b upon a. LHS, alpha plus beta, 0 plus minus 2 would be minus 2. And RHS, minus b upon a would also be minus 2. So LHS is equal to RHS. For the second part, alpha into beta is c upon a. LHS alpha into beta would be 0 and RHS 0 upon 4 is 0 because C is 0 in this case. So our second relation is also verified. Fifth part, the polynomial is t square minus 15. In this, the middle part is missing. So we can solve it directly by taking square root on both sides. So we will get t as 15 and root 15 and minus root 15. For the verification, first part alpha plus beta is equal to minus b upon a. Alpha plus beta would be root 15 plus minus root 15 is equal to 0. RHS minus b upon a, 0 upon 1 is 0. LHS is equal to RHS. Alpha, for the second part, alpha into beta is C upon A. LHS alpha into beta is minus 15 and RHS C upon A is minus 15 upon 1 equal minus 15. So LHS is equal to RHS. So the last part of this question is 3x square minus x minus 4. For this, we need two numbers for which the product is minus 12 and sum is minus 1. So our numbers can be minus 4 and 3. After solving this by factorization, splitting the middle term, we will get x as minus 1 and 4 by 3. For verification, we will find LHS alpha plus beta, which will be 1 upon 3, and RHS minus b upon a, which also will be 1 by 3. So first relation is verified. For the second relation, alpha into beta is equal to c upon a. LHS alpha into beta would be minus 4 by 3. RHS c upon a is minus 4 by 3 as well. So our both relations are verified. Second question is, find a quadratic polynomial each with the given number as sum and product of its zeros respectively. In this question, we are given two numbers in each part which are sum of zeros and product of zeros. Zeros are not given in this. So our general equation is x square minus sum of zeros into x plus product of zeros. We will use this relation to solve this question. So for the very first part, alpha plus beta is 1 by 4 and the product alpha into beta is minus 1. We will replace these both numbers in place of alpha plus beta and alpha into beta. So after taking the LCM, we will get 4x square minus x minus 4 as the required equation. In second part, the sum is given as root 2 and product is given as 1 by 3. So after replacing, we will get 3x square minus 3 root 2x plus 1. In the third part, we are given sum as 0 and product as root 5. So our equation would be x square minus 0x plus root 5 or x square plus root 5. In the next part, sum is given as 1 and product also given as 1. So our required equation would be x square minus x plus 1. For the fifth part, the sum is given as minus 1 by 4 and product is 1 by 4. So our required polynomial would be 4x square plus x plus 1. Sixth and the last part of this exercise, sum is given as 4 and product is given as 1. So our required polynomial would be x square minus 4x plus 1. So here we come to end of this chapter from NCERT book. In next exercise, we would take some important questions from this chapter. Thank you for watching. Stay tuned.